So here's something that I want to bring up right now, and that is that we've talked that proofs should go something like this. Oops, so let me get the pen. Okay, so I should be able to say A is equal to B, which is equal to C, which is equal to D, and then all the way down until we get is equal to Z, right? And this is a proof that A is equal to Z. Okay. Now, a lot of students actually want to do something that looks like this. A is equal to B is equal to C is equal to D. And then they go at some other place and they say, Z, well, that's actually equal to Y, which is equal to X, which is equal to W, and that's equal to D. And then they come look at these two things and they go, aha, so this is a proof that A is equal to Z. Okay. Now, the way that I've written it here with all those equalities, actually that is a proof that A is equal to Z. Okay. However, I do not want you to write proofs in this form. Okay. And the reason actually has to do with later proofs that actually aren't strings of equalities. Okay. So let me give you an example of the kinds of things that can go wrong. Okay. So what I like to do is I want to prove you that 2 is equal to 1. Okay, and I hope you realize that that can't possibly be true. Okay, but I'm going to try to convince you that it is, and here's how I'm going to do it. Okay, so I'm going to come over here and write something. Minus 2 is equal to minus 2. I think we can all agree on that, right? And here's something else that we know. 4 minus 6, that's just equal to minus 2, right? Substituting equals for equals is equal to 1 minus 3. Okay, that works. Okay, and now let's just add 9/4. Yeah, I thought we're all happy, right? And we're going to factor this. Okay, so this is 2 minus 3/2 squared, and that should be equal to 1 minus 3/2 squared. All right, so now let me go over on this side and let's do something different. I'm going to say 2 is equal to 1. Now, we don't believe that, okay? But let's say that that's true, and it is certainly the same as saying that 2 minus 3/2 has to be equal to 1 minus 3/2, right? I mean, those are equivalent, and I will square them. So 2 minus 3/2 squared is equal to 1 minus 3/2 squared. And you recognize that, in fact, those are identical, right? So I should be able to say, oh, this is equalities up to that. So therefore, minus 2 equals to minus 2, which, by the way, this is a true statement, right? Equals 2 equal to 1. So this must be true. Convincing, isn't it? I hope you're not really convinced. There has to be something happening here, and you probably figured it out. It's actually this step where we take the squares, because minus 3 squared is 9, 3 squared is 9. So it certainly isn't the case that you can simply remove squares and still have the same number, right? So going from, if you were trying to do this in the right way, then when you came here and started going back up, this step would not be justified. Okay, it's only justified in the direction coming down, not in the direction going back up. Those are the kinds of subtleties that can surprise you if you try to do these V-shaped proofs where you start at the beginning and start at the end, and then somehow try to meet in the middle. Do not do that. We simply don't do that in this class, and you shouldn't do it after this class either. But I do want to say something, and that is sometimes it's easier to start at the beginning and start at the end and then try to meet in the middle. Okay, so here's what I would say. We have A, and then we're going to do a whole bunch of kind of reasoning, and let's say that we get over to J. Okay, and we have Z on this side, and we're going to do a whole bunch of reasoning, and we get to J. Okay, that's not the proof. This is what I call scratch work. Okay. Proofs are hard. So, you know, it's unlikely that you're going to start with a blank piece of paper and actually write the proof from beginning to end with no mistakes. It can happen, yes. That's kind of like sitting in front of the computer, typing a program, hitting execute, and it runs the first time without any kind of debugging. That happens a lot, doesn't it? So don't expect to be able to do that. you need time to experiment. You need time to play. You need time to make it work. So after you do this, then what you need to do is simply rewrite it, okay? And so you'll have to say A is equal to B is equal to C all the way to J, okay? So we're going down this way. And then we'll continue going up this section. So that's equal to K, that's equal to L, all the way up to that's equal to Z. This is the way that you give me the proofs, right? This is for you. Okay? When you're trying to find a proof, by all means, do anything you can to find it, okay? It's a difficult task, it's a creative task. Do whatever you need to do, okay? When you're done, actually write it like a proof.